Good afternoon and welcome to another video on SAYS Double Word Physics P1. The date it was set on was Wednesday the 23rd of May 2018. It's the new spec, so it's the spec you're currently doing. This is Thursday the 15th of May 2025. We're looking for that. That's the magic number. Where we go. The nucleus of an element X may be written off. Remember, A cross zebra, number of protons, atomic number of nucleons, atomic mass. A and Z are numbers. What are the numbers called? Atomic mass, number, and atomic number. The following incomplete sentence describes radioactive decay. Complete the sentence by filling in the blank spaces. A nucleus decays because it's unstable and so emit alpha particles or beta particles or gamma radiation. Alpha. Whoops. Just move that a wee bit. Hold on a wee minute. That's a wee bit better. Alpha, beta, and gamma. If you don't know them, Wally. A radioactive substance has 8,400 decayed particles, and 90 minutes later, 7,350 particles have decayed. Let's have a look. 8,400, 4,200, 2,100, 1,050. 7,350 have decayed, so there's 1,050 left. How many half-lives? No half-life. 1 half-life, 2 half-life. 3 half-lives is 90 minutes. 1 half-life is 30. Be careful. That's what's left. That's how many have decayed. Structure of the atom. Now, it gives you a mark scheme. The names of the particles make them up. Proton, neutron, electron. Where are the particles located? Nucleus, nucleus shells. Good sentence, capital letter, good spellings, makes sense, not pure gobbledygook. Capital letter, full stop, good spellings. We're looking 6 marks. That's all we need to know. Hardly rocket science. On to the next one. Maybe you can hear outside somebody is using a strimmer or a lawnmower. A gardener pushes a lawnmower with an average force of 9 newtons. Work done equals force by distance. Do you know that formula? It's on your sheet. Did you learn it? Work's measured in joules, force measured in newtons, distance measured in meters. By the time the lawn is mowed, the gardener has walked a distance of 600 meters. The work done is force by distance, force 9 by 600 is 5,400 joules. Straightforward. Penalty kick that one. On another occasion, different question. He did 72,000 joules of work and took 15 minutes. Warning. 900 seconds. Yes. Don't fall for that. Calculate the power. Power equals energy over time. Energy's in joules. Look. That's joules. After dear old James Prescott. That's seconds. What is that? Correct. 80 watts. Power, energy, time. All matched. A mountaineer wears snowshoes. It's a pressure question. Pressure is force over area. Pressure is measured in pascals. Force is measured in newtons. Area is measured in meters squared. Pressure is directly proportional to force. Big force, big pressure. Small force, small pressure. It's inversely proportional to the area. Big area, small pressure. Small area, big pressure. Right, so get that clear. The snowshoes prevent her from sinking into the snow. Explain fully in terms of pressure why this is so. Pressure is inversely proportional to the area. Large area, small pressure. You won't sink into the snow. The mountaineer wears snowshoes of total area 0.5 metres squared and exerts a pressure of 1800 pascals. Look, have a match. Have a match up. Pascals. Tickety boo. Metres squared. Tickety boo. We're going to find the force in newtons. Calculate the weight. Remember, weight is a force. I'm working in my exam. I want every mark of that 70. Right, you've looked at that. I'm going to move on. There's no clicks in that one. A ball is rolled along a surface. The ball travels along the surface before coming to rest. During this time, the ball slows down at a constant rate and has an average velocity of 0.14. We did this on another video, average velocity. How do you find the average of a thing? Add them up and divide by 2. The initial velocity, that's the velocity at the start. Final velocity, that's the velocity at the end. Add the 2 of them up, divide by 2. 0.14. Is some number add nothing? Why did I say that? Rest. Nothing wild or exciting about that. Next question. The velocity time graph for a ball is thrown. Look what I have done again. I have written down what I need to know. I know it's a velocity time graph. Why? It says so. Acceleration is rate of change of velocity. Acceleration is the velocity at the end. Take away the velocity of start over the time taken. Initial velocity. Final velocity. Slot them in. Where's this bloody pair? Stop moving. No, take away minus 0.1. Don't forget the minus. There was a mark for that. Put them in where they're supposed to be. Naught. Take away 0.4 over 4. How would you use this graph to find the displacement? Look at my exam technique. I know. Now here's one of these ones where you have to add weights and take off weights and everything. Student is attempting to find the density of a gas in a balloon. Some of the students' data is shown. So there's the mass of the empty balloon, 12 grams. There's 0.8 grams of gas in it, and the volume of it is 400 centimetre cubed. Now, mass of gas plus mass of balloon is the total mass. So there's 0.8 grams of gas in it. Density equals mass over volume. Density, in this case, is going to be grams per cubic centimetre. The mass is going to be in grams, and the volume is in cubic centimetres. Slot them in. You might get that in the calculator. Shouldn't panic it. That's the same thing. And look, there was a mark for that. Mark for the unit. Didn't give you a unit that time. Slippy. The student places the gas-filled balloon in the fridge and cools it down. Sad old student. As a result of the cooling, the density of the gas increased. Why? You've taken some of the energy out of the gas molecules. They're now closer together, so they're more dense. So the distance between the gas particles decreases. The forces act on the car is shown. This is Newton's second law. The resultant force is newtons. The mass is in kilos. The acceleration meters per second squared. Look, 2,000 pulling that way and 800 pulling that way. That's the same as 1,200 pulling that way. Look, I have it in my diagram. The car accelerates uniformly at 1.2 meters per second squared. Calculate the mass of the car. Resultant forces, mass by acceleration. 2,000, take away 800 because they're in opposite directions, is equal to 1,200. That's the resultant force. Resultant force is equal to mass by acceleration. Look, there's the keep it simple, stupid again. So the mass is 1,000 kilos. You can freeze this at any time and have a look at this. You don't have to listen to my dulcet tones all the time. Describe and explain what would happen to the size of the acceleration if the frictional forces decrease. So if that gets smaller, that gets bigger. If that gets bigger, what's going to happen to the acceleration? If that gets bigger, the acceleration, they're directly proportional. If that gets bigger, assuming the mass stays the same. And the brakes are applied to the car to begin to slow down. In which direction will the resultant force now act? Backwards. To the left. Don't forget, if you are not ready to move on, go back a couple, freeze it, and look at it. Now the next question. State Hooke's law. Capital letter. Full stop. Proper spellings. Somebody has to read it. No gobbledygook, please. The force is directly proportional to extension, provided it hasn't exceeded its elastic limit. 2 marks. A force is applied to a spring as shown below. Its own length is 2.2. When I put half a newton on it, it's 4.7. So 0.5 newtons causes that. So 1 newton causes 5 centimetres. So the spring constant is 0.2 newtons per centimetre. Look, F equals KE. What's the force? 0.5 is equal to K times the extension. 4.7 take away 2.2, 2.5. So the K is equal to 0.5 over 2.5, which is 0.2 newtons per centimetre. Newtons per centimetre. Use the information that you're given to calculate the spring constant. Look, there's it all done for you. Again, freeze this. Have a look at it. Have a look at how I rearranged the formula. Did I get every mark? There was a mark for the unit. Newtons per centimetre. Newtons per centimetre. Newtons per centimetre. Newtons per centimetre. Newton centimetre to the minus 1. All the same thing. Freeze it. Look at it. Think. Graphs of force against extension for 3 different springs are shown below. Here's your force against extension. Now I'm going to do a bit of mapping. F equals K times the extension. That's on my y-axis. That's on my x-axis. I'm going to do a bit of mapping. Y equals mx plus c, straight line graph. The gradient is the spring constant. So that has a bigger spring constant than that one. And that one doesn't obey Hooke's law because it's not straight. Has the greatest spring constant, A, because it's the steepest one. Doesn't obey Hooke's law because it's not a straight line. Has the smallest, see the way, smallest extension for the same applied force. See the way I drew up this? There's all the same extension. Small force, bigger force, biggest force. So the answer is A. See the way I used the graph in the exam. Think. It takes time to think. Well, if I see these bloody equations anymore, I think I'll go nuts. See if you haven't learned that and learned the other one. You're going to miss these questions big time. Nuclear fusion. Remember we did this for the fusion. F-U-S-I-O-N. We'll put sun in there, and then we did that. A mnemonic to remember which one's which. And then we did fission, split. Do you remember that? Do you know the fission equation? Going to learn it night before the exam. Not remember it then. Isotope. Deuterium and tritium, high temperature, helium, neutron, energy. Isotope of hydrogen. Look, I have them written down here. Deuterium and tritium. Where would you find this? In the sea. The main byproduct. There's that, there, look. Helium. And what's the next question? Main environmental advantage. There's less radioactive waste, there's less CO2, and there's less global warming. I didn't say there was none. Here's one of the things I know you don't. How much energy per kilo does nuclear fusion release when compared to the energy of burning coal? 4 million times. State 1, technical difficulty that must be overcome before nuclear fusion can be used to produce. And the answer to that is, see that temperature? That is very hot. So whatever you put this plasma, superheated gas, whatever it would just vaporize all containers. So they're having trouble making the container to hold the plasma. They hope to use a magnetic bottle to hold the plasma. Maybe if you keep out the books, you could work on that. Last question. Golfer strikes a golf ball as shown in the diagram. A golf ball has a mass of that many kilos, that's all right. And it hits the ground with a velocity of 20 meters per second, that's all right. At point X, the highest point in the motion, the kinetic energy of the golf ball is that. By first finding the kinetic energy of the ball when it hits the ground. Formula. Bits and pieces in. Everything was right, no mistakes. So there's 9 joules of energy when it hits the ground. So, if there's 9 joules of energy when energy cannot be created nor destroyed but changed from one form to another, there's 9 joules of energy right along that path. Here, you have less kinetic energy and more potential energy. Here you have no potential energy. So the total energy is equal to the potential energy at X plus 5.5. The total energy was 9. Take away 5.5, 3.5 joules of potential energy at X. Energy cannot be created or destroyed. There's only 9 joules. There's 9 joules there. There's 9 joules there. There's 9 joules here. Up here. There's some potential energy and some kinetic energy. Down here. No potential energy, all kinetic energy. So there's all the energy. Is equal to the potential energy at the top, plus it tells you in the question, look, 5.5 joules. So the potential energy is 3.5 joules. Now we're going to use the potential energy. P is equal to M by G by H. We don't know H. .7 repeating when you use the calculator. What is it asked? Sneaky. 1 decimal place. 7.8. And there's another paper done. We have to learn to take our time. We have to learn good exam technique. We have to learn to think. We have to learn to slow down. And it takes your time to do all of these things. See you later. Toodle pip, old bee.